Okay, this is Andrew. We're going to take a presentation on static routing. You're going to need to be doing this in your project. And remember, we're not using any real equipment on the project, but basically you're going to need to show which static routes need to be entered on which routers. So if you remember this, we have a router, and each branch of a router is its own network address, its own network. So on this side, we have the 10.0.0.0/8 network, and on this side, we have the 20.0.0.0/8. For the rest of this presentation, I'll just call this the 10/8 and this the 20/8, or even the 10 network and the 20 network. Okay, so on this router, we have an IP address that is on the 10 network. It's a 10.1.1.2, and this IP address is from the 20 network, and it's 20.1.1.2. Now, in real life, we have to enter these IP. We have to go into the router and configure these IP addresses on the interface of the router, although you're not going to have to do that in this project. Okay, so let's go ahead and add a switch and two computers. And now let's discuss what happens when a PC wants to ping another PC, okay? If they're on the same network or subnetwork, then the router is not involved. But if they're on a different network, then it has to go through the router, okay? And the PC will just send it to its default gateway. Okay, so let's take a look at this. So I'm on this computer, and I go into the command line, and I say ping 10.1.1.101. So that's this computer here, and they're both on the 10 network, right? So if they're on the same network, then the router is not involved. So here's the frame, and it sends it the ping over to the 10 computer. And then it comes back. Okay, great. So you see the ping went down and the ping came back. That always happens with the ping. Now let's say that I'm on this computer and I'm in the command line, and I say, all right, let's ping the 20.1.1.2 interface of this router. Can I ping the interface of a router? Sure, we do it all the time for testing, troubleshooting, whatever. Okay, so the first thing this computer does is say, I'm on the 10 network and you want to ping the 20 network. Is that the same? No. So he says, I don't know what to do with it, so I'm sending it to my default gateway. Now, if you go into the computer, you'll see an area where you add your IP address, and there's also what's called a default gateway. And all that means is if it's not on this network, then you send it to the default gateway. So we would configure on this computer the 10.1.1.2 interface of this router to be the default gateway. So anything that's not on this network is just going by default to this interface. And basically, the PC is just saying, I don't know what to do with it. Here, router, you handle it. So up it goes to the 10.1.1.2. Now the question is, what happens on the router at this point? So let's go ahead and add a switch and a PC here. And then let's use a PC and a console cable to console into this router. Now this is not the same as an Ethernet cable. This is a rollover console cable, and it's plugged into the console port of the router. It allows me to do configurations on the router and to view configurations. So let's go ahead and do show IP route on this router, and that's going to show me the routing table. And you can see here that the router automatically, without us having to do anything at all, knows about networks that are directly connected to it. So the 20 network is directly connected to Ethernet 1 port, and the 10 network, all this over here, is connected to the Ethernet 0 network. And the router knows this. Okay, so the router can go ahead and connect that interface and come back. So now what happens, realize we pinged it, hit the interface and came back. So now what happens if I want to ping 20.1.1.100? That's this PC here. Well, what's the first thing the PC does? It says, I'm on the 10 network, you want to ping the 20 network. Is that the same? No. So I don't know what to do with it, so I'm sending it to my default gateway. So up it goes. Now the router looks on its routing table and it says, oh, you want to go to the 20 network. Well, I'm directly connected to the 20 network. I know where that is. That's out Ethernet 1. So he simply sends the ping request out Ethernet 1. And off it goes to the 20.1.100. Now be aware that there is some intelligence going on with the switch here, but that's beyond the scope of this discussion. Okay, so now let's just add another network, a 30/8 network over here. And we'll put these IP addresses on the router interfaces. Now we already proved connectivity from here to here. So really we can go ahead and get rid of this hardware. I mean, we can physically remove it, or we can just not show it on the slide at the moment. So we can pretend it's still there, but we're just not using it, so we're not showing it. Okay, so we want to ping the computer over here from this computer. So what's the first thing that this computer does? It says, are we on the same network? No. So let's just send it to the default gateway. So it goes here. Now the router has to decide, what am I going to do with this ping? Says, so the router has to either know how to get to the 30 network by a static route or a dynamic route that's in its routing table. And a static route is a route that we physically enter into the table, or a dynamic route is something that it's intelligently learned through a dynamic routing protocol. Or the router just doesn't know how to get to the 30 network at all, but it does have a default gateway that it sends it to. But we have to configure the default gateway. Just like on a PC, if it doesn't know how to get there, it sends it to its default gateway. The same thing here. But if there is no default gateway, and there is no route, then the router just dumps the data because it doesn't know where to send it. Okay, but we can go ahead and hook up this PC with the rollover cable into the console port and do show IP route, and then we're looking at the routing table. So we can see that this router knows about the 20 network and the 10 network, but not the 30 network, and we already knew that. But what we can do is we can go ahead and enter a static route. And so on router 1, this is router 1, we would go into the configuration prompt, and at that configuration prompt we're going to enter IP route, the network that we want to go to, which is the 30.0.0.0/8, which is a 255.0.0.0 subnet mask. This is the way you have to enter it. So that's the network and the subnet mask where we want to go, and then this is the interface we're going to exit out of from our router. So we're going to exit out of this interface E1. So great, let's go ahead and look. After we entered that, let's look at the show IP route, which just shows the routing table. And you can see that static route is now entered. It's the 30 network is there, and it's directly connected to Ethernet 1 right here. So great, the router knows what to do with it. It sends it out Ethernet 1. When it gets to router 2 over here, let's go ahead and hook our rollover cable up to the console port and take a look at the routing table. It knows about the 20 network because it's directly connected, and it knows about the on Ethernet 0, and it knows about the 30 network because it's directly connected on Ethernet 1. So excellent. So it knows exactly where to go. It sends it down because it's on the 30 network and it's wanting to go to the 30 network. It sends it down Now again, the switch makes some intelligent decision. There could be 20 PCs here. The switch is knowing which one to send it to. Great. So it's a ping and it's coming back. Now what's the problem? We came back here. We never entered a static IP route here, and it's trying to go back to the 10. It doesn't know how to get back to the 10, right? So again, you have to enter an IP route on router 2. So router 2, in the configuration prompt, you're going to enter IP route, the 10 network, the subnet mask, and the interface that you're going out of, which is E0. So you take a look, there it is. It's in the static route. The 10 network is directly connected to Ethernet 0. So it exits out. And once it gets here, of course, it knows where the 10 network is and sends it back. Great. So as a summary, you can see that, let's review quickly what we did. If it's on the same, we pinged this computer from this computer. If it's on the same network, the routing's not involved. The next thing we did was we pinged this interface. So we were able to ping to, the first thing it does, it says, okay, well, that interface is not on my network, so go to default gateway. But this router knows how to reach that because it's directly connected. So it pings the interface and then comes back to the PC. And now the case where we ping the 30.1.1.100 from the 10.1.100, again, it's on a different network, so it sends it to its default gateway, but once it reaches this router, it didn't know how to get there. So we have to have a static route that tells it IP route, the 30 network, going out the interface E1. So then it exits out the E1 interface, and then on this router, it knows the 30 network is connected to it, so it sends down, and then ping back, it's now going back to the 10. So when it gets up to this router, it doesn't know where the 10 is, so we have to do the same thing and enter a static IP route to get to the 10 network, and then off. So again, realize the switches are doing intelligent work here, but that's beyond the scope of this discussion. Okay, I hope that helps you out with understanding static routing, and I hope that helps you get through the project. Thank you.